Let's understand KMP. Say we have two strings, a main string and a pattern string, which we are going to search. To begin with, we are going to check them character by characters until we hit a mismatch. Now, if we were using naive algorithm, we would do the whole process again for each subsequent positions until we get a match. This is very time consuming. So let's analyze one possible answer. As this is the answer, these two portions of course matched. But that also means the beginning of the pattern and the ending of the green portion of that pattern also matched. Again, these two are the same patterns, so the beginning are the same. Ultimately, that means in the green matched portion, the suffix and the prefix are the same. So the key observation here is if we try to find a secondary match with a portion that already had a bigger match, we are basically searching for a repetition. And if there is no repetition, there is no match. On this part, I didn't have time to animate it. Let's just draw it. Let's assume this whole green portion matched with the main string, and the red part is where we found a mismatch. Also, inside this particular boundary, there is a 3-character repetition from the suffix and the prefix part. And here we are going to use our observation in the reverse way. If there is a repetition, there is a match. And in fact, this is true. So we don't have to check these 3 characters again. We can just say they matched. And then we can start checking on the yellow part where we previously were. And we take this decision based on how many repetitions there is. Let's say there is 1 character repetition in the suffix and the prefix in the boundary. That we say there is 1 character match. And then we start checking from the yellow part and so on. Now, to avoid repeated calculation, we can pre-calculate the longest prefix suffix and store it in an array called LPS. For now, we don't need to know the process of creating an LPS array, just know what LPS array is. Also know that we actually need all kinds of suffix-prefix matches, not only the largest one. But as we will soon see that we can generate smaller length suffix-prefix matches from the largest one. Thus, we are only storing the largest suffix-prefix matches. Now let's combine everything we learned. We have a main string, we have a pattern string, an LPS array, and we need to find a possible match inside of this boundary. The first step is to look at the LPS array at the last position. As you can see, it says there is a 3-character match from the suffix and the prefix portion of the pattern. So we can directly say there is a 3-character match from the pattern, and we can start from the 4th character marked as yellow part and start checking. But what if the characters in the yellow pointers did not match? We need another suffix prefix that is not the longest, rather a different length. But we did not store it. We need to find it from the LPS array. Now look at this part carefully. Very carefully. These 3 characters from the suffix and the prefix are same. Now, we are not going to use the second portion anymore, but rather we are going to use the first portion. From the first green portion, the corresponding LPS array says there is 1 character repetition from the suffix and the prefix part. That means these orange marked characters are the same. But again, these green 2 sections are same, right? So 4th and 6th character are also the same. So it also means the 0th character and 6th character are also the same. Do you see something? We actually found a suffix prefix of different length. Here, length 1. So we can say that one character has matched from the pattern without even calculating it at all and start checking from the second character. This is the whole concept of KMP string matching algorithm.